Any kind of like word problemy situation that could go along with this scenario? Just make it up. I start with $1 in my bank account. Every day I deposit $3. Every day. Right? How much money do I have? So X here would be the number of days, and then Y could be total money in my account, the total dollars. I'm just trying to give you sort of a scenario so that we're kind of coming back to the idea of word problems. We're going to do more word problems anyway, but we need to do more because that's something that people struggle with. Okay, so when we're going to do a table, here's the thing. We call X the independent variable, and Y is dependent. So that means that I could make up any values for X that I want. But if I'm going to want a graph on my axis, X, comma, Y, right? My X axis and my Y axis, I don't really want to plug in X as 100. Because if I use a scale, now what we're doing here, when we set up our graph, we're going to label the x-axis, label the y-axis. When we set up the scale, we want to count. But it can get a little crowded to go 1, 2, 3. So you could go 2, 4, 6, -2, -4, -6. I'm still using a scale of 1. Scale of 1 just means I'm counting by 1. Even though I counted by 2, but that's implied because this is 1, this is 3, right? I'm just skip counting. So I could go 2, 4, 6, -2, -4, -6. I just kind of like how that looks, even though I have to make sure I know that there's a number in between that I'm skipping. I like how that looks because it kind of gives me more open space and my numbers are not so crowded together. I'm also labeling the line, not the space. A lot of times they're like, oh, there's all this space in between the lines. Why don't I put the numbers there? Well, because we're actually identifying the line, this line right here, this whole entire line is where X is equal to 2. Right? Everything on that line has X equal to 2. So that's why we're labeled the line. So with our table, we can really use any numbers we want. But it's convenient to put in numbers right around the origin. So our favorite one is 0. Let's do, it doesn't say what numbers we should use. So let's just use -4, -2, 0, 2, 4, 6 maybe. That's a lot of different solutions. So all we're going to do here is if I want to know what the Y value is, I'm going to plug in -4 for X. So 3 times -4 plus 1, what's that? Yeah, -11, right? -12 plus 1 is -11. So -4, -11 is a point. Let's plug in -2. 3 times -2 plus 1, -6 plus 1 is -5, -2, -5. Let's plug in 0. Oh, does anybody notice how easy it is when we plug in 0? What do you get when you plug in 0? So that ordered pair is 0, 1. What do we call that point? Y-intercept. Yay! So we put little we love the y-intercept. Y-intercept, you're so great. Okay, 3 times 2 plus 1. Actually, I usually realize that in our table, we usually count by 1. I don't know why I did 2. You could count by really anything you want, but, okay, so what's 3 times 2 plus 1? 7, yes. So 2, 7. Okay, and you can kind of get the idea of how we're doing this. I don't know that we're going to be able to fit very many more on the graph. So now when we go to graph these points, once I have a list of ordered pair, and how many different ordered pair could I have? I could have really an infinite amount, okay? I'm going to plot these points. -4, 11, that doesn't really fit on my graph because I didn't develop a scale where that worked. -2, 5, -2 over, down to -5. Here's the point, -2, -5. It can help to plot and label the points. This is what it means to label the point. 0, 1. 0, 1 is here. It's the y-intercept, so it makes sense that it's on the y-axis. And then 2, 7 is here. 2, 7. So now we get our, once we have at least 3 points, I think you should always graph a minimum of 3 points. You get your ruler, and just like you learned when you were a little kid how to connect the dots, it's exactly what you're doing here. Connect the dots was preparation for graphing. I put arrows on the end. Why did I put arrows on the end? Exactly. It keeps going in either direction towards infinity. If you don't put arrows on the end, it's technically not a line. It's a line segment. Okay. Now here's something I want you to notice. This is going to come up later. What I like to do in graphing is, I hope it's not overwhelming, but I like to give you like a little sneak preview for what's coming up, because I think repetition is really, really important. So let me show you something about this graph. Remember we were talking about y equals mx plus b. And I said b is the y-intercept. 1. 0, 1 is the y-intercept. What is this slope thing? The slope, we're going to learn later, is rise over run. Okay? How much I go up, 1, 2, 3 over 1. I go up 3 over 1. Here, up 3 over 1, up 3 over 1. It's like stairs. So 3 over 1, that means from every single point on the graph, we're rising 3, we're running 1. And that's going to come up later. We're going to get to slope, okay? So for the next table, it probably would be a little bit more convenient if you did things like -3, -2, -1, 0, 1, 2, 3. That's typically how we do that. And for 4 here, we're going to do the same thing. We're going to plug in our x values. You're going to do that in just a moment. I want to point out something on the next page. Here, let's plug in -3, -2, -1, 0, 1, 2, 3. And then for the one that has the fraction, it's really, really hard to graph a fraction unless you use the scale. You can use a scale of a fraction. If I counted by one, if I counted skip count 1, 2, 3, because I have a half in between, this is actually a scale of 1/2. But still, how many of you really love working with fractions? Anybody love it? It's your favorite thing ever? Okay, so I'm going to give you a clue as to how you can make sure that the points you use do not end up as fractions. If you use x is -4, -2, 0, 2, 4, 6. Why did I counted by 2 in my table. Why did I use counting by 2 or multiples of 2? Yes, I'm using the denominator of 2 to determine that I want to count by 2. Because look what happens. Well, first of all, if I plug in 0, I get y equals 1/2 times 0 plus 5. Don't you think it's silly that I should even have to write that one? What is that one going to be? When x is 0, what's y going to be? 0, 5. And what is this point called? Y-intercept, okay? If I plug in 2, 1/2 times 2 plus 5, what's half of 2? 1. What's 1 plus 5? 6. So 2, 6. Okay? So I just want you to see that. And you don't have to necessarily use a scale of 1/2. You could use a scale of 1. You also can use a different scale on the y-axis and the x-axis too. So you could still count 2, 4, 6, -2, -4, -6. And here I used a scale of 1 on my y-axis, and this is my x-axis. So we always want to write the scale, draw, label some points so that we indicate what our scale is, and we always want to have label our axes. Okay, so that's just a little bit of a clue. Whenever your slope is a fraction, you can change the x values in your table so that you don't end up with fractions, because you don't really want to graph half. You don't want to graph half, you know what I mean? Unless you use that scale.